All right, today's lesson will be on combination circuits. You'll hear me call them complex circuits sometimes as well. So combination circuits involve a pretty thorough process when solving for voltage and current. And today we're just going to focus on the resistance part. This will typically have to be done first, and you'll want to keep it very organized with pictures. That'll then make the voltage and current solving much easier. So I know this is a complex circuit because I see, first off, a junction right here with two paths, but I even have a resistor before it, which means it's in series, and I even see two resistors right here that are back to back in series as well. So this one's kind of complicated. There's a lot going on, but this will be good practice for us. So what we want to do when solving for the total resistance is we want to actually simplify the resistances down to combinations, or what you'll hear called equivalent resistance, and then we'll work our way all the way down to some total resistance. So this takes practice, but the thing you have to do first is you have to try to isolate two or maybe three resistors that have just a series or just a parallel relationship with one another. The tricky part is, though, there has to be just those resistors in series or in parallel. So for instance, a lot of people will think these two are in series because, okay, there's one path right there. The issue with that is that there's actually a junction in between them. And we know series is only one path, so they are not in series just yet because of that junction. All right. Another one that is commonly mistaken is maybe these two. So there is a junction then where the current splits right there, and you would think they're in parallel. Close, but this resistor is on that individual pathway as well. So that is not just parallel with those two resistors yet. We still have to do something about the other 6 ohm resistor on that individual path. So the first one for this is actually these two. So at the junction, the current has split, but once it goes down this individual path, these two are in series with one another because they are the only two resistors on this path, and there is no junction within this path. So what we do, and this is important for when it gets a little bit more challenging with current and voltage, is we redraw the circuit, and I'll try to be kind of quick with this. So not going to do anything to my 12 ohm. There's the junction right here. All right, the current's going to go down that inside path. Still the 24 ohm resistor out here. Not going to do anything to that. But what I'm going to do is I'm going to solve for what we call the equivalent resistance of now this combination. So they are in series, so this one's actually easy. If I were to give these resistors names, call them 1, 2, 3, and 4. I would then call this the equivalent resistance of resistor 2, 3. So next to this simplified resistance, I would put, all right, this is going to be this combination, the equivalent resistance of both 2 and 3 combined. They are in series, so it is pretty simple. I'm just going to show some quick work down here, that it is 6 ohms plus 6 ohms, and that equivalent resistance then is 12 ohms. All right. So again, this was the first simplification I could do because these two resistors are back to back on a single path without anything else interfering like a junction or another resistor. Okay. What we then do is we just continue this process. I'm trying to find either 2 or 3 resistors that can be simplified again. So again, some students might look at this one and say, all right, are those in series now? They're still not because there's a junction between them. All right, so be cautious with that. These two, however, are now on individual pathways, and they are the only resistances on those pathways. So now these two actually are in parallel with one another. So we are going to then redraw it again. 12 ohms, nothing's happened to that. But then this outside split path becomes 1 because we're going to simplify it. All right. So this would be called, again, being mindful of my names right here, this would be called the equivalent resistance of 2, 3, and 4. And resistor 1 is still 12 ohms up there. This is in parallel, so let me kind of zoom out a little bit. The equivalent resistance, or just total resistance equation for when they're in parallel, is not as simple as just adding them up. It's the inverse. And we know that with adding fractions, you have to get a common denominator. So I'm going to multiply this by 2 to get it to be 24. So I'm going to have 2 over 24 plus 1 over 24. This then equals 3 over 24 ohms, but remember, it's 1 over RT. So we have to flip that or cross multiply, whatever you want to do. The equivalent resistance of 2, 3, and 4, not quite the total yet, is 8 ohms. 24 divided by 3 is 8 ohms. All right. Now, the last picture, I think it's pretty clear that with these two left, we of course have a series relationship left because there's only one path. So, draw a final circuit. This part I know a lot of people tend to skip because they're like, I'm done, I don't need to do anything. Do it for the sake of the next lesson, which is a little bit harder. But when we find this total resistance, which is now total, I could call it that for sure, it's going to be 12 ohms plus 8 ohms, and that of course equals 20 ohms. All right. So I got this image. If I go out of my notability right here, I got this image from a worksheet that is on Canvas for you guys. I'll link it right there. So we actually just did this one. Notice I did not do it on the worksheet though, because there's no space to draw the pictures, and I'm just telling you right now, do not try to do these without drawing pictures, because when we then go to solve for current and voltage, you will struggle big time. So the first two, again, if you want to call them 1 and 2, these are not combination. First one's a parallel, second one's a series, just to practice. Third one we just did, we got a total resistance of 20 ohms. I want you guys to do 4 and definitely 6, but if you want to practice 5 as well, that's perfectly fine. Okay, if I can give you a little tip with 6, because this is again a pretty detailed one, the first one to start you off is right there. So those two in series I would start with first. Okay, number 4, I'm gonna let you guys try to figure it out. I will actually end up posting the answer key though, not with all work shown, but just the total resistance. So if you later compare your answers and you're a little off, just recheck it and think about which ones you can simplify first, okay? All right, good luck everybody. This is really important for the next lesson, so please take the time on this, and remember, test is at the end of the week.